Yeah, all this OBS stuff broke on me 2 weeks ago, and then I
Hmm.
just got hammered and was sick, and I haven't been able to figure it out. But for whatever reason, whenever anyone that's listening early on right now, if you know why switching OBS scenes with video sources is causing lag on video streaming, let me know because it's really annoying. But yeah, so that's what's going on there.
Yeah,
But
I have an audio setup here that's pretty brittle. Maybe brittle is the correct word, because I share the same keyboard, mouse, monitor, and external sound card between the work laptop and my desktop,
okay,
and I have two KVM switches for that
gotcha.
because I already had one that could handle the mouse and keyboard, but it doesn't handle the sound card pretty well. And I got
Mm,
a cheaper one just for the USB switching. And sometimes I just boot into Windows, let's say, for whatever reason, and it just doesn't recognize the sound card
yeah, that's
at all.
irritating. Yeah. Yeah, sometimes I'm tempted. I just want maybe just a Linux box for doing streams, and then I don't have to worry. I mean, maybe I would have to worry about other things,
Well,
but
audio drivers in Linux
are more difficult, right? Yeah.
is a problem of its own. Yeah.
Yeah, that makes sense. Hey, what's up, Saul? All right. I'm going to go ahead and kick this off. What's up, guys? I'm Jacob Blitzo, your Elixir Mentor, and welcome to another exciting episode of the Elixir Mentor Podcast. This is where we discuss everything related to Elixir, from interviews with enthusiasts, pioneers in the community, to innovative projects and libraries shaping Elixir's future. Today, I'm thrilled to welcome Paulo Valente, an R&D software engineer and maintainer of NX, the numerical Elixir ecosystem. Welcome to the show, Paulo. It's awesome to have you here. Do you want to go ahead and just kind of give a brief introduction of yourself?
Yeah, thanks for having me. You gave already most of the introduction that I normally give. Uh, I want to highlight that I work at Dockyard, and most of the NX work that I do is on Dockyard time. So it's pretty important for us to recognize that.
Yeah, that's amazing.
And
Dockyard is does amazing stuff for the Elixir community.
yeah, and as you can see around me, I'm also a musician by hobby mostly. And actually, yeah, I got into programming and DSP, signal processing, and then machine learning because of music. So
Oh,
that's a
that's
nice
cool.
curiosity.
Yeah.
Yeah, and I work with an X.
Yeah, very cool. What kind of started you um to get into the Elixir world? What pulled you in?
It was mostly just coincidence because in late 2017, early 2018, I was looking for an internship because I needed a mandatory internship for graduating college. And a friend of mine that he's still around in the Elixir space, but not quite as much, Bernardo Amorim.
Mm.
Um, he was working at Stone, a fintech in Brazil. And he basically, when I was gonna start looking for an internship, he asked me if I wanted to go work there. So things lined up nicely. But I my coding challenge was in Python, and then 1 month or two after I joined, uh, we started moving towards Elixir.
Okay.
And long story short, we built an online bank from scratch using Elixir,
Wow. That's cool.
and I worked there for almost 5 years, 4.5.
Okay, nice. And then what brought you towards the creation of NX and that project?
Hmm. Well, as I mentioned, one of the main reasons for me to become an electronics engineer was so that I could work with music, even if on the side. So besides me, I have a guitar amplifier that I modded like 2 months ago, and it's my main driver right now. Um, so always like looking for applications of engineering towards music. And during college, that meant doing a research internship in audio processing, and that's in that space that I learned most of the linear algebra that I know, and also I started learning machine learning,
Okay.
AI as a whole. And then I ended up not doing my project in that space, my graduation project in that space, mostly because I wanted to do it in Elixir and focus more on the functional programming and distributed system side of it, because that's what I was working with at the time.
Hmm.
This is like mid 2019. So I ended up doing a project that's related to machine functional programming systems for managing machine learning subsystems, which meant that the MVP was Elixir calling into Python via gRPC. And then with that bridge, we could consume data, images from different video streams, batch them, and then send them to the classifier that was in Python, and then get the results back and unbatch the results.
Mm.
And if this sounds familiar, it's because it's basically an X serving. But yeah, I did that in mid 2019, and there was always this internal urge for me to work with machine learning or something in the space in Elixir.
Hmm.
And then, unbeknownst to me, Sean and Jose started working in on NX in the late 2020, and then they published the library in early 2021, and that's when I started working in the project.
Okay, very cool. That's awesome. For people that may not know, can you explain, like, in the simplest terms you can, what
Hmm.
is NX and how does it help Elixir and what does it actually do for us?
Okay. Um, First, NX stands for Numerical Elixir. And the reason that we need a project like NX is because of how the Beam works. Beam, the Elixir VM or Lang VM, because um, it's always trade-offs, right? So because we want a platform that's built for concurrent programming, the trade-off there is that functions in general have to give up control of the system every 4 milliseconds if they aren't done. This means that computations that take longer than that will be even slower than
Hmm.
what they would be. And that, coupled with some of the other data structures that we have on the beam, makes it so that number crunching, especially linear algebra type of crunching, that's the basis of machine learning and AI, those aren't suited for the beam VM.
Hmm.
And then NX can leverage Elixir's metaprogramming, the ability to turn code into other data structures instead of just spitting out the result. We can take advantage of that to then start lowering down the code until we can call into uh, C functions, for instance.
Hmm.
So NX is the higher level interface for doing number crunching in Elixir. That's
Okay.
the short summary.
Okay, very cool. And that's like when you'll hear examples of people like adding Rust to their stacks and things, NX would kind of alleviate you having to bring in another language, right? It's like the high level version of
Well,
getting low
NX
def.
kind of NX kind of already does bring that. Not NX itself, but NX is built with pluggable backends.
Mm,
So for people in the Elixir space, that's like Tesla having a Hackney or Finch type of client, or Acto having adapters for other databases than not just Postgres. It's the same interface, but the implementation and the functions that are available aren't necessarily the same.
okay.
And NX does that. And then we have backends, which provide the individual functions. And we can also provide compilers, which take whole NX functions, NX computations, and lower them down into machine code as a unit.
Mm,
But those libraries, they do have their native code.
okay.
The ones that we wrote officially, they use C++, but that's just because it's the common language that we know.
Mm-hmm.
We have Ortex, which is in the Elixir NX or GitHub organization right now, and Ortex is written in Rust.
Okay.
Explorer is written in Rust as well.
Okay.
And both of those provide NX backends, or at least part of backends as well.
Gotcha. Okay. Very cool. For those that are like are new and like me, I don't know much about numerical computing or anything, but you'll always hear the term like tensor thrown around. Um, can you kind of explain to us what that is? Like, is it close to what a list is, a matrice? What is it?
I was having this discussion with a friend of mine this earlier this week because we're going through a deep learning book, like a book club of sorts. And the simpler answer is that you can think of tensors as lists of lists.
Okay.
So going from lower dimensions to greater dimensions, we have scalars numbers. So 1, 2, 10, 1,000,000, they're all scalars. It's just a single number. We have vectors, which are just lists of numbers. There is a discussion whether a vector is just a list of numbers, but for this purpose, let's think of just being a list.
Mm-hmm.
And then a matrix is a list of lists, and they all need to have the same size.
Mm-hmm.
And then there's the tensor, which is the generalization for more dimensions. So that's one way to think about tensors. And uh, we can we can maybe do some analogies here, not analogies, but really connecting these abstract concepts with something that people are familiar with. So let's think about a video. Each pixel is a scalar.
Okay.
And then if you're talking about RGB video, RGBA, with the transparency channel as well, each channel is a matrix. So the red channel is just a matrix of pixels. The blue channel is the same, green and alpha, all the same shape, the same width and height, each one with different values, but it's just a matrix for each channel. If we're talking about a JPEG image or PNG, like RGBA images, those can be thought of as 3D tensors already because it's a list of matrices.
Okay.
You have width, height, and channels. And then when you step into the fourth dimension, you can think about time, for instance. And that's a video. It's a list of images over time.
Okay.
So a video can be thought of as a 4D tensor in that sense. It seems a bit disconnected, but when you start working with the lower level data, manipulating images as tensors, this becomes a bit more evident. But I know that it's a bit out there to just say that a video is a tensor.
Yeah.
So, yeah. But really,
It
it
hurts
can
my
be.
brain a little bit.
Yeah. And then the important thing is that when you step into higher dimensions, things can be interpreted in different ways. So you saying that a vector is a list of numbers is one thing, but maybe you just want a list of numbers. It's not like a unit,
Hmm.
uh, measurement unit, the vector. And then a matrix is the same. You can just have a list of vectors. And when you go into higher dimensional tensors, the interpretation really will depend on what the person is doing. So there's not really much more that I can use to define a tensor than just a list of numbers,
Gotcha.
a deeply nested list of numbers.
And from the aspect from like just the higher up macro view of them, what are they used for? You're using them to analyze and compare data types and data, right?
Yeah, so if you're doing image filtering, for instance, you need to represent the image in some
Sorry
way
if you
that you
guys
can.
hear my dog. He's dreaming behind me.
Uh, if you're doing image processing, you need to be able to represent the image in some way that you can manipulate mathematically. And then if you load the image as a tensor, then you can use all of the linear algebra constructs that we have out there to operate on that data structure. It's the same thing as asking, hmm, I need to count frequencies of letters in a text. What's the best data structure? It will depend on the sub problem that you want to solve. For instance, if you're doing arbitrary encodings such as UTF-8, UTF-16, and you don't want to restrict yourself, maybe you want to accumulate a map. If you're just counting Latin letters, the 26 of those, and not do and do it in a case insensitive way, then maybe an array can be like an array with 26 entries might be enough. And then the advantage of the array is that you don't keep allocating memory over time. The map will grow over time,
Hmm.
and that might be a problem. And there's no good answer to, hey, this is the best data structure right now. But when you're talking about getting something as a list or a collection of numbers and then doing mathematical functions on that collection, probably some type of tensor representation is going to be the best way to go.
Hmm. And what makes it so much better? Just because you don't have your unknown like length of arrays or a growing map, you is it like confined to rules or what makes it?
It's mostly because if you have the concept of a tensor, you most likely have the linear algebra functions or
Gotcha.
functions that can perform operations on tensors defined along with it.
Okay, I
It
see.
generally comes the other way around. Hey, I want to apply these functions to tensors. Okay, let's create a tensor representation.
Okay. So you
Yeah,
start with your algebra and then you get your representation in the tensor form.
yeah.
Gotcha. That makes sense. That's cool. Um, when we're talking about like this is correct me if I'm just like not making sense, but there are like three main capabilities of NX, right? You have like tensors with type to data, and then you have your numerical definitions, and then like automatic differentiation, right? Is that, or would you be able to kind of walk through those and talk about
Yeah,
them a little bit with us?
yeah. Uh, s- we we have the tensor representations as we have been discussing, and along
Yeah,
with those, the
we can X
functions.
that off.
Yeah. Um, and then the numerical definitions gets into that metaprogramming aspect that I was mentioning.
Okay.
It it's just a easier way of writing NX functions. You don't need defense. But what you need is, imagine I want to get a sequence of computations, sequence of functions to be treated as a single unit. I can wrap that into a function. It might be a defn, but it could just be a simple Elixir function. And then I call into the inputs with NX functions. If I'm just using NX functions for building the output, then NX can use one of the backends that we provide, which is the NX-defn expression, to trace through the computation. And instead of spitting out a number, it spits out an AST, a representation of the computation in terms of data.
Mm-hmm.
So if you have an addition operation, you're going to have a node that says, hey, this is an addition with these arguments.
Mm-hmm.
And that's the power of that fan. It's being able to restrict the subset of Elixir that you can use for NX.
Okay.
And then the output of a defn, the intermediate output, is a defn expression. And because it's code represented as data, we can do stuff with that. And one of the things that we can do is automatic differentiation. But we can do other things as well. Um, really, anything that requires understanding the code as a structure and not just values, just the values that the function splits out, an xdefn will be able to, the defn expression will be able to help with that.
Okay.
And then, yeah, after we have the defn expression, we can then pass that on to a compiler, which gets into what I was talking about earlier, where there are some backends that are also compilers, and they can get those functions lowered down into machine code as a unit.
Mm-hmm.
But maybe you don't have a compiler ready, and then you just traverse the, we have the defn evaluator, which traverses the defn expression and then calls into the specific backend functions uh,
Okay.
underneath.
I
Uh,
think I get it.
yeah, it's a bit hard to grok. It's too much information almost. Um, maybe a more concrete example. So if we step up from NX to Axon, the neural network library,
Mm-hmm.
Axon has layers, and each layer is treated as a unit of uh, computations for the purposes of Axon. But whenever you're calling from, you have a defn and you're calling into another defn, the AST will propagate. It's not the values that are being passed. So
Mm-hmm.
you can accumulate the AST over, And this means that an action model is just a big definite expression with some other stuff around as well. And then you have a function that takes in parameters and outputs something. And the parameters are not just the input, but also the weights of the neural network. The media is always saying when you see announcements about LLMs and whatnot, oh, it's a 70 billion parameter thing. It's
Mm-hmm.
because besides the input, you have 70 billion numbers somewhere in there, which are passed as arguments.
Okay.
And then what you want to do is for training, you pass an input and then you know the expected output and you know the actual output that the function gives. Then you apply what we call a loss function, which is basically how wrong you are. And then if you have a way of differentiating the function, the loss function, then you can use that to modify the weights back. And that's the power that a def gives. You don't have to define how the differentiation happens.
Okay.
You're using automatic differentiation for that,
Mm,
but it this is just possible because it's all code being represented as data
right.
before it executes.
Okay. All right. If we take all of this stuff that you've just kind of explained to us, can you kind of put it into like a real world example that from the standpoint of a developer, how you would even begin to use NX and like what's a good project where you would start implementing it?
Well, if you're aiming to learn NX and machine learning, the simpler examples are probably the best ones. In Axon, there are some guides there, and maybe start with those.
Mm-hmm.
So things like representing the XOR function as a neural network, and then training the neural network to give off the proper result. That's maybe the simplest example that you can have. And then you can step up to digit classification, which is another one of the bread and butter examples that we have. And then after that, you can start uh, threading your path in machine learning more
Okay.
easily. Because in working with those, you learn about supervised learning, which is this um, um, concept where I have the input and the expected output as a pair, and then I can use those to train the neural network. That's supervised learning. Um, and then you learn about that. You learn about the how to use Axon at least, and then if you need an X, you're probably gonna need a specific subset of NX, and then you can go in the documentation and see how to use that. And as you step up to digit classification, you're already moving from a regression problem to a classification problem, and then you start learning about different types of machine learning problems. And that's at least how I learn things. I like starting from a higher level concept
Mm-hmm.
and learning the details as I see the holes in the knowledge. And not only as I see them, but as I see that I need to fill in those holes.
Yeah. Well, I feel like this is a very easy subject to jump too far in too quick, and you can get
Hmm.
overwhelmed because there's a lot going on.
Yeah, If you're doing like depth first learning,
Yeah.
you're probably gonna end up looking into bits and bytes, and that's too far deep.
Mm-hmm.
And maybe depending on what you want to do, the linear algebra stuff is too far deep because we have Bumblebee. If you're an Elixir developer that wants to have an AI application, AI function running in your app, but you don't really want to learn how to build one, maybe Bumblebee already provides the model that you want to run, and then it's just a like 4 lines of code to get that as a process that you can call into in your application tree.
Okay. I see. Yeah. Can you explain what Bumblebee is a little bit for us?
Hmm.
I think it's just like learning models, right? That you can apply to what you're doing without LLMs, right? Or I might be wrong.
It's not just LLMs, I think, maybe. Um, but really, what Bumblebee is we have NX as the foundation, then we have Axon for neural networks, and above Axon we have Bumblebee, which takes in uh, configuration from Hugging Face, which is a separate uh, repository for machine learning. Think of it as GitHub for machine learning.
Okay.
Bumblebee can load models from Hugging Face into Axon models. So you need to define some code in Bumblebee for that to happen, but in the end result is that we have a way of getting the configuration off of Hugging Face and import that as an X code. And then you can apply everything that we have been talking about so far. But if you don't want to, you can just use that and X code. I think it spits out an Axon model, and then you can get that and just use an X serving, which is a functionality in an X for spinning up a process that can handle batches of data for a given function. Then you just spin that up and run with your model. You
Okay.
don't need to go too deep. You can just stay at the Bumblebee level if you want.
Yeah, that's
Uh,
nice.
Yeah, I've
Um,
demoed this a bit in the Denver Elixir meetup. There's an online recording somewhere out in on YouTube
okay.
if people want to see like how to connect Bumblebee with a live view, for instance.
Yeah, very cool. I'm checking out the Bumblebee GitHub right now. And apparently, hopefully people can hear me. I bumped my gain quite a bit. Apparently my audio is a little quiet, but yours is good.
Hmm.
So hopefully, maybe I'll just kind of go crazy on my gain. Dude, OBS, man. It's nothing but trouble lately. I might have to find a new alternative. But anyways, hopefully you can hear me now. Nero, do I sound better or is it still quiet? We'll just assume it's probably a little better, but I'm probably still on the low side. When it comes to like handling performance optimization with NX, are there like specific things that you need to do to make sure you're keeping the performance that you need?
Uh, there,
It's probably really hard to.
there are some things that I mean the most important one is to make sure that your code is running with a native backend such as EXLA or EMLX. And besides that, if if the computation doesn't change too much over time. So if you're passing, if you're always passing the same shape of data as input, then you might also want to use a compiler if available.
Okay.
Generally, the complaints that I get of, hey, this is too slow, is mostly due to people not configuring the backend compiler properly.
Mm.
And then that's one thing. The other is stay in an X lane as much as possible. So one quick example. Imagine I have a list of angles that I want to calculate the cosine of. And the list of angles is represented as in an X tensor. A simple way would be to do a for loop and apply the cosine at each position. And then I get the number and store that somewhere. The fast version is to just call an X cos on the tensor itself, and cos is an element-wise operation. It
Okay.
already knows how to apply itself to the tensor, and that means that you didn't leave an X length to calculate the loop of the cosine. And then, I mean, that's a pretty simple example, but as soon as you get to more complicated functions, or you're translating functions from math into an X, then maybe you need to change the way you think about the code a bit
Mm.
to make it fit into the paradigm of um, vectorized computations.
I see. We have a question from George. He said, "Can you
Mhm.
describe again what is a backend and what is a compiler?"
Yeah. Um, so NX provides a behavior, nx.backend, which lists uh, quite a few callbacks that you need to implement for the NX interface to call into. So the backend is just that. It's a way of turning the NX call into some result. And the backend can do whatever it wants, really. In general, you want to calculate the actual functions, but not always.
Mm.
And the NXDefn expression is one example of that, where instead of spitting out numbers, you're spitting out um, a an AST, kind of like using def macro instead of def.
Right, right.
Uh, but the backend is just that, and then you can implement that in Elixir itself, which is the NX binary backend that comes with NX, or you can call into C functions from somewhere else. That's the backend. The compiler is doing almost the same, but instead of being called into by an X, whenever you do an x.add, for instance, an x.add is going to call a backend. But if you do an x-defn compile, JIT apply, or you have a globally configured compiler and you do a defn and call the defn, all of those are going to call into the compiler that's configured. The compiler is going to take in not uh, an x add or an x subtract. It's going to take in a function and the arguments.
Okay.
And then whenever you do that and you call the function with the arguments, you get the expression that represents that function. And then it takes that expression and transforms it into native code. It doesn't need to be native code, but that's generally why you want to do a compiler.
Okay, that makes sense. And your performance and everything is probably a lot better when you're down in native code, right?
Uh,
Or no?
yeah, and
Yeah.
it is. But the thing is, when you do a compiler, you're you also have the ability of the underlying code that you're using to do operator fusion and whatnot. So one example is EMLX, the backend and compiler that we have for running on Apple GPU,
Hmm.
Metal. And EMLX without the compiler is about 5 times slower than with a compiler.
Oh, wow.
And yeah, it's a pretty big difference.
Yeah, that's, someone, let's see, at the very beginning. Oh, we had Mark. He's curious to hear about the new metal support. Great timing. And so that must have been a new feature recently added.
I don't, it might have been like 1 month ago exactly
Okay.
that I decided that maybe it was time to not just try to keep using an Xerie, which is another backend compiler that we have. That's the first thing that we tried to bring metal support into an X. And then I decided, hey, MLX seems to be stable right now. Maybe we can use that. And MLX is the official Apple library
Mm-hmm.
for for machine learning. So we put together a team that uh, me, Samrat, Coco, um, like most of the comments were by us three, and in like 10 days we got the whole backend done.
That's amazing. That's good.
With
Nice.
yeah, I was really impressed. Uh, Aside from like specific options and specific functions that are harder to implement, but most of NX already works with the backend. And I just now yesterday I sent a pull request for the compiler.
Okay.
It does some crazy stuff because it needs to call it back into Elixir from NIF land, which
Okay.
is pretty uncommon. And if we were doing this like a month ago, it wouldn't be possible because Coco's library didn't exist yet.
That's
But
wild.
yeah,
Yeah.
we called back into NX, into Elixir to run through the function that NX defines, but with the tracing arguments that MLX provides. So that it spits out internally at least the equivalent of what we have as a definite expression, and then um, MLX can compile that down into a function, and then we just get that function, return it to Elixir, cache that, and then pass that with the list of inputs into another NIF that will do the actual function call.
Okay. Is most of is the back end and like the compiler, are these mostly like GPU tasks, or how does that work?
Um, Not necessarily. I wouldn't say mostly they can run on
Okay.
GPU, but for instance, if you're talking about MLX, Macs have an unified memory architecture. So you doing stuff on the GPU or on the CPU boils down to what does what faster.
Okay.
GPUs are highly parallel, but they don't do sequential stuff really well. So if you're doing a loop over and over the same data, maybe doing that on the CPU is going to be faster.
Okay. Now, is this something that is automatically figured out, or is this something that has to be done in configuration?
It has to be done in configuration.
Okay.
Right now, we might be able to say, hey, you're trying to run this on the GPU, but
It's
you
not
should be
efficient.
running on the
Yeah.
CPU. Yeah, but we're definitely not on that stage
Yeah,
yet.
yeah. No, I mean that was probably a dumb question. I was just
No,
I didn't know.
no, definitely not a dumb question. In general, it's it's hard for someone that's not in the space to differentiate between sequential code and parallel code,
Mm-hmm.
and parallel code versus concurrent code. Because the magic of the GPUs really is that you're truly parallel. You're not
Gotcha. Yeah.
concurrent. I mean, you're concurrent in the sense that the GPU is a resource, but as soon as you have a computation running on the GPU, it can take over of the GPU at once if it needs to.
Mm-hmm.
And then that's why running things on the GPU is a lot faster. GPUs are built for doing highly parallel computations over the exact types of computations that we have in neural networks,
Okay.
which is matrix and vector products mostly.
Gotcha. Yep.
That's where the GPU shines.
Okay. That makes sense. And that's why like Nvidia stocks are shooting through the roof right now.
Yeah. But then when you get to something like the Fourier transform, which is really common for non-machine learning stuff, GPUs don't do that too well.
Okay.
Like the CPU implementations tend to be, if not faster, at least as fast
Okay.
as
Interesting.
GPU. So, and then you don't have the overhead of transferring data to the GPU.
Okay, that makes sense. Are you able to have these like if you have different tasks, can you have different configurations set up that like this goes to the CPU and this goes to the GPU?
You have currently you can, but currently you have to split the computation manually for that to
Okay.
happen. But the work that I've been doing the past 3 months in sharding and partitioning functions, one of the things that stems from that is that you can annotate an X function with metadata and then basically get it to be split up between different execution stages.
Oh, okay, cool.
And then each execution stage will be able to be compiled down to whatever target you want.
Nice. Okay. That's cool.
And the goal here is for us to be able to get maybe the first two stages to run on the current machine, and then the third stage to run on a separate machine. If we have clustering, that should work just fine.
Okay.
And then the machines don't need to be the same hardware.
Oh, wow. Yeah, that's
I
cool.
can cluster my Mac with my Linux machines and then have the native code for each one run.
Okay.
The communication happens via Elixir, but
Like over
um,
like node or like a distributed system then? Yeah. Okay.
yes,
Yep.
exactly that. And like just being able to compile out different hardware is already enough. But even in the same machine, you can have a section that runs on the CPU and a section that runs on the GPU.
Mm-hmm.
I brought this as an experimental thing to an X series even, uh, but it probably needs to be redone. Where there are certain functions that don't work on Metal yet
Okay.
on that backend. Then I take the computation and split it up so that those functions are running on the CPU.
Okay. That's
And then
awesome.
you
Yeah.
go back to the GPU to run the rest.
And could you potentially then kind of treat it like a load balancer as well, across your resources that are available?
Um, I wouldn't say a load balancer because that's more on the NX serving type of functionality.
Oh, okay.
At least in the sense of balancing loads of how many requests you have versus how many machines you have, or
I
how
guess
many
I the
executors you have.
when I
But
said
it's,
that, I was meaning more like the
yeah,
amount of work being
balancing.
allocated.
Yeah, if you want to have, imagine you're running on desktops, like there's one desktop there, there's another right beside me, and this machine. Imagine all of the three, all three of those are used by people.
Hmm.
You don't want to hog all the resources,
Right.
because people might be using those for whatever. Then maybe it makes sense for you to run most of the code in the machine that you're using, and then take over parts of the other machines, just for, um, maybe the model doesn't fit in your machine. But
Hmm.
really, the least splits that you do is probably going to be faster.
Okay. Yeah, that makes sense.
But yeah, there are a lot of things that you can do when you have that kind of granular control.
Yeah, no, that's really cool. I love that.
Another thing that we might be able to do, or at least that's one of the things that I want to get working by February. Imagine you have a cluster of beam nodes. You can build a graph that tells you which nodes are, what's the least latency path without loops between those nodes, like, just so that in the end you can take a computation, split it over all of those nodes in such a way that you're doing the least splits with the least amount of latency possible.
Nice. Yeah. That really like
That's,
there's your performance optimization, right? The lowest latency and
yeah.
yeah.
But then that's not a machine learning problem anymore.
Yeah.
It becomes like distributed systems graphs,
Right. Yeah.
that type of problem space.
Mhm. It's just how you're handling your machine learning problems.
Yeah,
Now you're going to need like some version of DevOps just for that part.
yeah.
What is like when you're setting up like when you're using like distributed nodes and things for processing machine learning problems, is it normally like local host things like are is it like lab like you know desk testing things or are you running servers all over the world to do stuff with like larger projects?
Mm, imagine you have a, a web app, for instance, and then it does a lot of stuff. And one of the things that it does, it requires a machine learning task. But it just doesn't do that, it does other things as well. It might make sense for you to have multiple web nodes, and then have those web nodes call into a separate single GPU node, just for that machine learning task.
Okay. So it's if you have a web app and you do a machine learning task, have a separate resource just for that.
Yeah, that's not necessarily what you want to do. Like, if the machine learning task is the main thing that you do,
Okay.
maybe you want to keep them closer. But generally, it's one of many moving parts.
Mm-hmm.
Um, and then an X serving can handle that for you. The the Denver Meta demo that I mentioned. I start by developing things as a single node, and then I I start two nodes, one of which one of those has just the NX serving, and the other has just the web part of the supervisor tree.
Okay.
And because it's name registration in a global aspect, the whenever you call an X serving batch to run from the live view, it will call into the other node automatically.
Okay. Cool. That's really
Like
cool.
you
Yeah.
change the supervision tree, but not the code
Mm-hmm.
that's called the NX serving.
Okay.
And then if you have multiple um, nodes with the same serving, then it does load balancing and that type of stuff.
Okay. And that's taken care of in your NX serving
Mhm.
for the load balancing part? Nice.
Yeah.
Okay. That's cool.
So you can have 20 web nodes and 2, 3 GPU nodes,
Okay. Yeah,
and,
that's really
and
cool.
things will work
Man, I have a
out.
lot to learn. I love that. That's very cool. My mind is getting blown over and over right now.
Yeah, but really keep in mind keep in mind that all of these concepts that we talked about, they keep appearing as the relevant questions are being asked.
Mm-hmm.
So really, it's just too much stuff to learn, or it seems too much, because we're talking for too long without you going back and, oh, I have what I need to do what I wanted to do right now, which is the process that you're following when you're developing something.
Yeah.
It's like, hey, I need to solve this problem. What do I need to do? What do I need to learn? Oh, I need to learn this. Okay, I can solve the problem. Hey,
Right.
I have a new problem. What do I need to do to solve that? It just gets overwhelming when you're talking about many
Like,
problems in
yeah, when you're
sequence
just
without
taking a
solving each one.
macro overview
Yeah,
of everything, right?
exactly.
But that is true. Like, anytime you're learning something, it's best to start your own project, right? And then, yeah, you run into problem at a time that you have to solve versus 100 problems at once.
Yeah. And then things get less overwhelming
Yeah, for sure.
when you do that, plus the thing that I mentioned, where maybe you want to go depth first, but limit the depth
Yeah, yeah. No,
of the
I get
search.
like a lot of times I'll like to like read something about a subject, right?
Hmm.
But then you'll find yourself reading and like learning too much where you start to not grasp things. And that's where I'll stop. And then you just have to start at step one.
Yeah.
Yeah. Like I need to go back and just kind of wrap my head around tensors and then we can continue.
Yeah. Just to highlight for people listening, it's this stuff that we're talking about in learning. It's not just machine learning, it's learning in general. That's the same process of learning that I apply for everything I learn.
Hmm.
Like find a motivator problem, use that to bootstrap the low level knowledge, but not too much, and then go into a separate problem that adds something. And then if you do that over and over, you're closing the gap between the higher level knowledge and the low level knowledge until
Yep.
you fully grasp the subject.
Yeah, that's great advice. I love that. That's good. Um, so what's on the roadmap for NX that you're like most excited about that you can talk about? You don't have to talk about anything that you're not ready to, but
Well, I'd say the sharding and partitioning thing that I mentioned.
yeah, that sounds really cool.
We talked about partitioning, which is sequential splits in the code, but there is also sharding. Sorry, there is also sharding, where imagine going back to the cosine example. To calculate the cosine at each position of a vector, you don't need to get the data from other positions, right? And that means that if you split the computation up, calculate each data piece separately, and then stitch the results back together, you're going to get the same result.
Mm-hmm.
Which means that if you want to configure your code to be split up, let's say you get a matrix and then split that into 4 parts and get 2 of those to run on the GPU and the other 2 to run on the CPU. Or you have multiple GPUs in each of those processes, one of the parts, and then you stitch the results back together. Then you might be able to handle um, more data or handle data in a faster way.
Mm-hmm.
So both of those have the aspect of being able to handle more data, which is really important for in a time that like the run of the mill LLM requires 80 gigabytes of RAM or something.
Yeah, that's wild.
Like I have that on my desktop, but in RAM, not in VRAM,
Right.
right? And yeah, you need to be able to split up your computation if you want to run that on your machine, or if you need to reduce costs by getting
Mm-hmm.
a cheaper GPU, then maybe you, instead of splitting it up on different machines, you do splits over time.
Right.
You do one thing, save the results disk, the other thing, save. And if you do that in the correct sequence, you get the same result slower,
Mm-hmm.
or maybe not, because if you couldn't run it anyway beforehand, anything is faster than infinity.
Yeah.
So
Yeah. If you kill your
infinity
resources.
time, exactly. So yeah, I think sharding and partitioning is what starts bringing X in a different direction than what Python is going into.
Yeah. Well, it's if it's like at least from my point of view, it seems like it makes it a lot more accessible to the average dev that just wants to play around.
Yeah, but it's not just the average dev, because you can start. Let's take a small company. You can start developing on your dev machine, and
Mm-hmm.
then you just expose that as a service, and then you start getting money, and you can get like the same machine because it's probably cheap because you already had that before the company.
Right.
So you can buy the same of the another of the same machine and then run on that and start bootstrapping yourself without having to increase hardware costs exponentially. Because
Mm-hmm.
if you're doing cloud stuff, like 1 month or 2 of cloud costs, if you need to run 24/7, already covers the cost of having your own hardware,
Yeah, for
depending
sure.
on what you're doing. And then yeah, a medium-sized company, and oh, I need more clients. Okay, you have the beam, and the beam can solve the clustering for you, and
Mm-hmm.
Xserving can do the load balancing. So it's easy to start going up in size without having to have the cost rising the same rate. The
Right.
cost can rise a lot slower. And that's one of the things that sharding, partitioning, and next serving can bring.
Yeah, like it allows you to do like horizontal scaling at a very small scale.
Yeah, but also if you're going into the data center clustering direction,
Yeah. Yeah, it
because
all works the same way, right?
exactly because of the beam.
Yeah. Magic.
And then it's a lot easier for us to bring machine learning from Python to that than bring the beam
Yeah, that makes
to
sense.
Python.
So, with that being said, does that mean like the Python has a lot of limitations when it comes to doing these kind of things where you do need sharding and like resource splitting?
It's harder. You have Axel Labs that does partitioning, maybe
Okay.
sharding as well, in Python using MLX. They need to use gRPC for transferring data between nodes.
Okay.
We have native RPC.
Yeah.
That's already a pretty strong argument, I'd
Yeah.
say. And the beam distribution is pluggable as well. We're talking about configure backends on Tesla and NX. The beam distribution itself can be configured in different ways. So if you have a really specific network type, then maybe the beam can leverage that.
Yeah. That's awesome. It's kind of like the beam was accidentally made for machine learning.
Yeah, well, or the joke that everything has already been invented.
That too, right?
Uh, maybe up until 1986, and then everything is just a rehash.
Yeah, that's true. That's probably more likely, right? Or the simulation got reset somewhere and we're just starting over.
Yeah, but really, neural networks are maybe something that came. I'm almost sure that neural networks came before Erlang was a thing.
Yeah, I would think so, right?
Yeah, we just didn't have the compute power.
Right. At least like theoretically they were there.
Yeah, and but then you have something that's built for distributed compute and concurrent work. It was built to handle like as many people as people exist, right?
Mm-hmm.
That's for telephones, so
Yeah,
it's peer to
wild.
peer. And then that same scale still happens. It's just that we have more people, but it's still scaling with the number of people, the number of
Right.
requests that we have. Or okay, we have bots and so on, but really the bulk of legitimate product requests that are going to happen is going to be scaling with number of people.
Right.
And then at that scale, Erlang shines,
Yeah. Yeah.
and we have the same power.
Yeah. It's wild that all of this was figured out in 1986.
Yeah.
It's cool. I mean, it just kind of shows you that like the we run into the same problems throughout time, right? And it's kind of just the media shifts. Like instead of telephones, it's still data over wires, right? It's still kind of the same thing. It's just a different way we're using it.
Yeah. Maybe a nice way to look at this is if you're just looking from the top down, it might look like we're going in circles, but it might just be spiraling up.
Yeah, there you go. Yeah, that makes
Like
sense.
it's almost the same thing, but it's with more accumulated knowledge with
Hmm.
different resources available. Uh, One example, the MLX compiler that I wrote this week. 3 weeks ago, when I first looked at the problem, I was going for a different type of solution. But then the NIF call library came about, and I was able to incorporate that into the solution space that I could leverage. And then the resulting code was a lot simpler and didn't require me going in the internals of MLX.
Mm.
So it really is me going back to where I started, but with a different starting condition.
Yeah, you a tool was enabled to make your life a little easier.
Yeah, and that made the whole difference. But this happens in the larger scale as well.
Hmm. Yeah, yeah,
Like your phone is maybe maybe it's likely faster than the whole world's computing power at the time that we went to the moon. The whole
Yeah.
world,
Yeah.
not just like the rocket computer. I'd
Right.
say maybe all computers,
For sure. Yep.
and it's just your phone. Maybe your Apple Watch even
Right. Yeah.
might be might be faster. Not as much memory, but faster.
Yeah.
And that's crazy to think
That
about.
is crazy. It's crazy that like our phone would not even fit into like a huge building.
Yeah. And fun fact, if you have an iPhone and you're running Live on Native, we can run an Xcode in our application.
Oh, really?
Yeah.
That
The it's still unreleased, but the talk that I gave in at ElixirConf was compiling an X to some code that we could deploy to the iPad and run it natively without sending data back to the server.
oh wow. That's cool.
And I use the iPad because that's the iOS device that I have, but it should work with the iPhone as well.
Yeah. I would think it'd work the same way, right?
Yeah,
That's cool. So you can have an NX server running on on an iPhone.
kind of like that.
Yeah.
It, think about it in the next function
Okay.
instead.
Okay. That's cool. I like that. I'm LiveView Native is a cool project. I need to spend some time with it now. Now that it seems like it's in a pretty good spot to start playing around with.
It is. It is. Dockyard is starting to accept contracts for
Oh,
native
nice.
applications.
That's great. Yeah. Yeah, I think it's a game changer for at least adoption in the Elixir space.
Hmm. I'd say that everything that brings Elixir into a different direction than, or into a different space than what it was already present,
Mm-hmm.
helps with adoption.
Yeah, absolutely.
But
Absolutely.
I do think that we need to have that. Um, we need to think about documentation. It's not just documenting for other Elixir people. We need to be able to document for people that know the thing but don't know Elixir as well.
Mm-hmm.
I think you need
Yeah, like
the two pillars
you need
to have
the
good documentation.
documentation and the like adoption guides.
Yeah, maybe that's one way to think about that.
Like you already know machine learning, right? But you're coming from Python. So here's your adoption guide for Elixir.
Yeah, maybe a cheat sheet between
Yeah.
NumPy, PyTorch, and X.
Yeah,
That's
exactly. Yep, that's the hardest part, right? Adoption, bringing people over.
mm-hmm.
Because I mean, I'm a good example. I had a buddy telling me to check out Elixir for like I want to say like 4 years before I even checked out Elixir because you're just busy learning whatever you're currently doing. Like I was, head down just Node.js world and I didn't have time. And then when I finally made the time, then I didn't want to touch JavaScript anymore.
Yeah, I mean, comparing to JavaScript, it's pretty easy to choose.
Yeah, I agree. No brainer, right?
Yeah.
But this was awesome. I feel like I have to like absorb our conversation for the next like day or 4 days. I feel like I learned a lot, but it was awesome chatting, Paulo. I really appreciate your time, and you're always welcome to come back on, and we can talk about this stuff more. And hopefully, over the next year or so, I become a little more acclimated to the NX and machine learning world because I am starting to make it a priority because it's
Hmm.
a lot of cool stuff is happening in this space.
Yeah, and lots more to come. There are lots of things that we didn't discuss as well.
Yeah.
So, yeah, it's a pretty pretty interesting space.
There's a lot going on. You're a smart dude, and I appreciate your time.
Oh, thank you so much.
Yeah. All right. If you guys need to find Paulo, I have all the links in the description on, at least I don't think X has descriptions, but on YouTube and on Twitch, you'll find his Twitter handle and GitHub and all that good stuff. So definitely check him out. And I noticed also that the NX project is looking for like supporters and donations. So if you guys can, that would be a great place to do it because it's a really awesome project. So make sure you guys check out Paulo and follow him on, are you on Twitter and Blue Sky? You're on both, right?
Yeah, I'm on both.
Okay, cool. So make sure you guys give him a follow, and I hope you have a good weekend, man. Thank you so much.
Testing.